Figures 20.6 and 20.7, Iterator categories and the Iterator category hierarchy. In the next two figures, we're going to take a look at some more concepts with regard to iterators. And basically, like I said, these are one of the fundamental concepts when working with the standard template library. Now, part of what you're going to need to know as you work with both the containers of the standard library and the algorithms for processing those containers is the types of iterators that you have available to you, because certain algorithms require certain minimum iterator capabilities. So we have 5 different categories of iterator types, which you can see here in figure 20.6. You have input iterators, which are used simply to read elements from a container, and these types of iterators can walk only in the forward direction, one element at a time, through the container. You have similarly an output concept, an output iterator, which is used to write a value into a container. And again, an output iterator can only move one element at a time in the forward direction through the container. Separately, we have the combination of what is an input and an output iterator, and those together create what we call a forward iterator, which is an iterator that can walk forward through a collection one element at a time, and it can either read a value from the collection, or container rather, or it can write a value into the container. And in all 3 of these cases, the iterators that we're talking about are really for use with what we call one-pass algorithms. That means they walk over the elements of the container exactly once. If you were to operate with any kind of algorithm that needs to go through a container or a collection of data more than once, for example a sorting algorithm, these types of iterators would not work. The next category we have is the so-called bidirectional category of iterator, and that combines all of the capabilities of forward iterators with the ability to move in the backwards direction as well as the forwards direction. So bidirectional iterators that can go backwards and forwards can also be used with so-called multi-pass algorithms such as sorting capabilities. And then finally we have random access iterators, and these are the most powerful iterator category. Such iterators can do everything that a bidirectional iterator can do, plus you can randomly jump to specific elements within the container as well, kind of like using the square brackets operator in an array, where you can say I would like to jump immediately to element number 10 of an array. You can do the same thing with a random access iterator on a container that supports random access iterators. Now, these 5 categories of iterators also form an iterator hierarchy. And this is not a class hierarchy. Basically, at the lowest level of iterator, you have input and output iterators, and these two feed into the concept of a forward iterator, which has both input and output iterator capabilities. And then the next more powerful iterator is bidirectional. So a bidirectional iterator can do everything that a forward iterator can do, plus go in the reverse direction. And then finally, the most powerful type of iterator, once again, is random access. Now, as we move through our discussions of the container classes and eventually the algorithms of the standard template library, one of the things that we'll be talking about are the types of iterators, or the categories of iterators, I should say, that each type of container supports, and similarly the minimum iterator requirements for using a given container with a particular algorithm as well.